Let's do it.
The automotive world has been watching closely, and for good reason. Matt Armstrong just accomplished something Bugatti's own CEO publicly declared impossible. He reassembled a Bugatti Chiron per Sport in a regular garage and fired up the W16 engine for the first time.
Let's do it.
Whoa, it's starting on! It sounds pretty good. It sounds good.
The gearbox mounting bracket that triggered this entire rebuild has been repaired and reinstalled. A custom Valvetronic exhaust has replaced the factory system. And when Matt turned the key, 1,500 horsepower came back to life in a Miami garage, despite Bugatti CEO mate Rimac insisting this kind of independent rebuild simply couldn't be done. Here's exactly how it happened. When Matt first tore the Chiron apart, he discovered the root cause of everything: a cracked gearbox and engine mounting bracket. This single casting connects the W16 engine to the gearbox, and without it, the car is nothing more than an expensive pile of carbon fiber and aluminum. Repairing or replacing it was non-negotiable. Matt had two options. Option 1. 3D scan the broken bracket and CNC machine an entirely new one from solid billet aluminum. This approach would produce a piece potentially stronger than the original cast part, but it carried serious risk. If the crank sensor positions deviated by even a fraction of a millimeter, the engine could throw fault codes, run poorly, or fail entirely under boost. Option 2. Take the original bracket to a welder and find out whether it could be repaired. Cheaper, lower risk in terms of sensor alignment, but only viable if the material cooperated. Matt chose to explore option 2 first. He brought the broken bracket to Bob, an experienced welder, for a material assessment. The results came back positive. The bracket is cast from 7075 aluminum alloy, a high-strength aerospace-grade material and, importantly, one that responds well to welding. Bob confirmed he could restore it to original strength, possibly beyond. But Bob didn't stop at a basic repair. He went further, adding structural reinforcement in the hollow sections of the casting, areas Bugatti had left open purely to reduce manufacturing costs. When Bob finished, the repaired bracket was stronger than it had ever been from the factory. The decision was made. Bob's weld would hold the W16 to the gearbox. The expensive CNC route was shelved. With the bracket repaired, reassembly could finally begin in earnest. The flywheel bolted to the crankshaft using precise torque specifications, specs that Matt sourced not from official Bugatti service documentation, because that doesn't exist in the public domain, but from factory assembly footage on YouTube. Actual German technicians building actual Chirons, frame by frame. The gearbox mated to the engine. Electronic wastegates were installed. The solenoids that control gear selection were carefully plugged in, each one numbered during disassembly to prevent any mix-ups on the way back together. Then came the moment of truth. The entire engine and gearbox assembly was lifted into the air, suspended from Bob's repaired bracket. It held. No stress cracks. No movement. No failure. Bob's weld worked. Then the first serious setback hit. While torquing the 14 titanium bolts that attached the rear subframe to the front monocoque, one of them snapped.
Oh no!
Matt had applied 70 Newton meters across all 14 bolts, the correct specification for most of them, but not for 4 slightly smaller bolts located underneath the car. Those required a different torque value, and the error snapped one clean off inside the carbon fiber tub. Extracting a snapped bolt from a carbon fiber monocoque is genuinely delicate work. Carbon fiber doesn't tolerate the same brute force extraction techniques you'd use on steel or even aluminum. If the attempt went wrong, the car would have to be split again, weeks of work undone in a single mistake. Matt proceeded carefully, and the bolt was removed without further damage to the tub. Crisis averted. Assembly continued. While working through the broken bolt situation, Matt was also installing the custom exhaust system that had been in development for weeks. A fully bespoke setup from Valvetronic, hand-fabricated in titanium and designed specifically for the Chiron's W16. The system features a 2x6 double X-pipe configuration with merge collectors engineered to optimize both flow and sound. Every dimension was custom. Every weld was done by hand. For a car this complex, with an engine configuration this unusual, building an aftermarket exhaust from scratch is an enormous undertaking. But Matt made one additional modification that Valvetronic didn't design into the system. The Chiron runs two sets of catalytic converters. The primary catalytic converters are actively monitored by oxygen sensors. Remove those, and the ECU will throw fault codes immediately. But the secondary catalysts, positioned further downstream, exist purely for additional emissions compliance. No sensors monitor them. No computer cares whether they're intact. Matt gutted them, physically destroyed the internal honeycomb structure, the precious metal substrate, and left straight hollow pipes in their place. The result is functionally a straight piped exhaust on the secondary side, while the primary cats remain untouched to keep the engine management system satisfied. Maximum flow, maximum sound, zero fault codes. The Valvetronic system bolted into place. Heat shields were reinstalled over the exhaust routing. The rear crash structure went back on with its deliberately brittle titanium hardware, bolts specifically designed to shear in an impact to protect the carbon tub behind them. Then came the full electrical reconnection. Engine ECUs, transmission control unit, ABS sensors, brake wear indicators. Every connector that Matt had carefully labeled and documented during disassembly went back to its home. The documentation process that seemed obsessive at the time paid off completely here. Brakes were bled until solid pedal pressure returned. The accelerator pedal was installed. The transmission ECU slid back into its mount under the driver's seat. Then Matt positioned the $40,000 lithium-ion battery under the car, set 4 bolts, and connected the terminals. The dashboard lit up. The Chiron had power for the first time since it was torn apart. FXG climbed into the driver's seat. Matt stood outside, watching. The moment that the doubters, and Bugatti's own CEO, said would never come had arrived. FXG pressed the start button. The W16 fired on the first attempt.
Whoa, it's starting on!
No hesitation, no cranking, no coaxing. It lit immediately, and the sound that came out of it was unlike anything the car had produced in factory form. The custom Valvetronic exhaust with its gutted secondary catalyst had completely transformed the acoustic character of the engine. Deeper, louder roar. Where the factory Chiron sounds refined, almost deliberately subdued, engineered for quietness and regulatory compliance, this one sounded like what it actually is. A 1,600 horsepower quad-turbocharged hypercar with nothing left to hide. Matt's reaction was honest. He'd hoped for a transformation on the level of bolting a straight pipe onto a naturally aspirated V12, that dramatic, immediate shift in character that makes bystanders stop walking and turn around. The W16 doesn't deliver that, and it can't, because of what it fundamentally is. For turbochargers absorb and muffle exhaust pulses before they ever reach the tailpipes. The W16's architecture, essentially 2 narrow-angle V8 engines sharing a common crankshaft, produces a firing order that's inherently smoother and less aggressive than a high-revving naturally aspirated engine. No exhaust system changes that. No exhaust system makes a W16 sound like a Lamborghini V10 or a Ferrari flat-plane V12. The architecture simply won't allow it. What the Valvetronic system did accomplish is something more specific. It made the W16 sound like the most extreme version of itself. Louder than factory, deeper than factory, more present and more aggressive, but still unmistakably a Bugatti with that distinctive, layered turbocharged character. Compared to what Bugatti's engineers deliberately tuned out in the name of refinement and noise regulations, the difference is substantial. The Chiron no longer sounds like a luxury grand tourer. It sounds like a hypercar. Then, mid-celebration, fuel started pouring out from under the car. A fuel line had popped off under the pressure of the running engine. Matt and FXG shut everything down, located the connection, reseated it properly, and restarted.
Just press the pedal. Yeah! Moving.
The second start was clean. Engine running smoothly, no leaks, all systems nominal. Then came the gearbox test. FXG pressed the brake, pulled into gear. Every solenoid engaged. Every electrical connection Matt had made held. The transmission shifted. The car moved under its own power. Throttle input produced a response. Everything worked. The Bugatti Chiron Per Sport, a car mate Rimac said couldn't be rebuilt outside of Bugatti's own facilities, was running, shifting, and responding in a regular garage in Miami. There is still work ahead. The front radiators need to be installed. The cooling system needs to be filled and pressure tested before anyone finds out whether running the engine without coolant caused any lasting damage to seals or gaskets. Body panels need to be fitted and aligned. Final detailing and testing remain. But the hard part, the part everyone said couldn't be done, the part Bugatti's leadership used as evidence that independent rebuilds were futile, that part is finished. Matt Armstrong proved it on camera, in front of millions of people, with a repaired bracket and a YouTube torque spec. The Chiron is coming back to life.